So we've done vector spaces. Precisely infinite vector spaces. The vector spaces which have infinite number of elements, right? And we have done the linear independence of vectors, right? And also we have done the linear span or linear combinations. Right. So now what we're going to do, we'll be using these three concepts and try to find a new set, right? And that set is called the basis, right? So see, what is the basis? V be a subset of a vector space V, then so B is said to be the basis of V if two conditions should hold. And these are B should be Li. And next is B spans V. Now, what do you mean by B spans V? That means linear span of B should be equal to V. Or in other words, we may say that each element of V can be expressed as linear combinations of elements of B, right? So now this is just a definition, and we'll understand with the help of geometry and with the help of examples that how basis works and why basis is the important stuff for us, right? And I'll add one more definition to this, that is dimension of the vector space. So we are talking here, we'll be only talking about finite dimensional vector space. See, the vector space itself has infinitely many elements, but its dimension is finite. So what is its dimension? Dimension is nothing but number of elements in the basis. Number of elements in the set B, right, in the basis is equal to the dimension of vector space, right? So let's understand how this stuff works. So now consider a set, and that is 1 0 0 1. Is this set Li? Just mark these vectors and can you tell me, is this set Li or not? They should not lie on the same line passing to the origin. Are they lying on the same line passing to the origin?
No, sir.
No. So clearly, I mean, in this particular example, you can visualize and say that these are Li. So otherwise, you may also prove that. So let's say you call it as V1 and V2. So you'll write it as alpha 1 V1, alpha 2 V2 should be equal to 0. Now, alpha 1 1 0 plus alpha 2 0 1 is equal to 0. So alpha 1 0 plus 0 alpha 2 is equal to 0. So that means alpha 1 alpha 2 is equal to 0 0 vector. So that means you have no choice. Your all alpha i's are 0. So therefore B is Li. Is it fine? So this is our first condition, right? So this is our first condition. We have proved the first condition that B is Li, right? Next, I'll claim that B spans R2. That means every element of R2 can be written as the linear combination of elements of B. So let's take an example. You pick 5, 3. So can you write it as 5 times 1, 0 plus 3 times 0, 1? Yes?
Yes, sir.
Okay. So what do you get? You get that this 5, 3 can be written as the linear combination of these two vectors. And we have suitable scalars over there so that this vector can be written as a linear combination of 1, 0 and 0, 2. So can we do for every vector? Yes, we can do 1, 3. Let's say if I take 0 root 2, even then it's fine. 0 times 1, 0 plus root 2 times 0, 1. Is it okay?
Yes, sir.
Yes,
So
sir.
how we prove this part generally? We have taken two specific examples, but how we prove this part generally? So for this we take let AB belongs to R2. Now let's say AB can be written as alpha times 1, 0 plus beta times 0, 1. So your AB can be written as alpha beta. So that means your A is alpha and your B is beta. So this alpha beta you always need to determine, right? So your AB can always be written as A times 1, 0 plus B times 0, 1. Yes, that's why for the 5, 3 we have written 5 times the 1, 0 and 3 times the 0, 1. And similarly for 0 root 2 we have written 0 times this and root 2 times this. Yes, are you with me on this? Right?
Yes, sir.
So every element of R2 can be expressed as the linear combination of set B. Okay, now see this. So what we say, therefore, B is basis of R2. Does it fine? B is basis of R2. Therefore, dimension of R2 is equal to number of elements in B, and that is equal to 2, right? And we can also see that we have x-axis and y-axis, so dimension is 2, right? Is it fine?
Yes, sir.
बोलो ठीक है तो अब देखो next is let's say I have I've changed the set and then my new set is something like right. So now can we prove that is this a basis or not? For proving that B is a basis of R2, we need to prove two things. One, B should be Li. Second, B should spans the R2. Are you with me on this?
Yes, sir.
So let's say start with the first part. So if we want to prove that B is Li, so of course we need to prove this stuff. Or for a moment, you just write it 0 over here. So alpha 1, V1, 1, 1, alpha 2, 0, 1, 0. So alpha 1, alpha 2 plus 0 alpha 2 is equal to 0. So, sorry, I mean, here it should be alpha 1. So alpha 1 plus 0, alpha 1 plus alpha 2 is equal to 0. So that is 0, 0 vector. So now if you equate those things, so your alpha 1 is 0, alpha 1 plus alpha 2 is 0. So since your alpha 1 is 0, so if you put this value over there, so that means your alpha 2 is also 0. So therefore your B is Li. So the first step is covered. So the next part is B spans R2. So for this, we'll take any general vector. Let's say AB belongs to R2. And let's say if it is possible, AB is equal to alpha times the 1, 1 plus beta times the 0, 1. So your AB is equal to alpha, alpha plus 0 beta. So your AB is equal to alpha, alpha plus beta. So your alpha is equal to A and alpha plus beta is equal to B. So what should be your aim? In this question, your aim should be, you need to determine this alpha and beta in terms of A and B, right? You need to determine this alpha and beta in terms of A and B. So for this, now you have already determined the value of alpha in terms of AB. That means only A you are getting. Fine, fair enough. So you put value over there. So what do you get? A plus beta should be equal to B. So from here, you also get the value of beta, that is B minus A. So that means if you want to write down any vector AB in terms of 1, 1 and 0, 1, you will always write A first, because the value of alpha is A. So here you will replace A times the 1, 1 plus. Now you want the value of beta. So here it is beta, and here you have, determined the value of beta. So here you'll write it as B minus A times the 0, 1. Right? So from here we can say that B is basis of R2. Right? So now before moving to the next question, let's make few notes over here. Note 1. Okay. So can this be the basis of R2?
No.
Okay, so what would be the possible reason? Is this Li?
Yes, sir.
Yes, sir.
So what is the problem?
Sir, it has only one dimension.
Exactly. So this is Li, but cannot span R2. Then what it can span? Yes,
IR.
only x-axis. है ना?
Yes, sir.
सही बात है? एक ही dimension span कर. And same holds for the 0, 1 as well. 0, 1 can span only the y-axis, right? Okay, so if I say this, be a basis of R2.
No.
Why is it so? What is the problem in this set? Can this set spans R2? It can span R2, but what is the problem? It is not linearly independent set. Why it is not linearly independent set? Because in the last lecture, I have told you if any vector of a set can be expressed as the linear combination of its other vectors, then the set cannot be linearly independent. Right? So you see this, your 2, 3 can be written as 2 times the 1, 0 plus 3 times the 0, 1. So it cannot be linearly independent. In other words, we can also prove that 2 times 1, 0 plus 3 times 0, 1 minus 1 times 2, 3 is equal to 0. So now you see that alpha 1 v1 plus alpha 2 v2 plus alpha 3 v3 is equal to 0, but all alphas are non-zero. हमें तो कोई एक ही non-zero चाहिए होता है, right? Even if we get one of them is non-zero, then we say that the set is linearly independent. But here we are able to produce alpha 1, alpha 2, alpha 3 so that all are non-zero. So that means this set cannot be linearly independent. this spans R2, but not Li, right? So these are two different things. So earlier, the first set was like, this set is Li, but cannot span R2. And in this example, this spans R2, but not Li, right? So what does that mean? That means that, always keep in mind, right? So I'm putting the third mode over here. If B spans, let's say, or any other set, right? Let's say if S spans V, then any superset of S will also span V. And if S, let's say S dash is Li, then any subset of S dash is Li. ठीक है?
Yes, sir.
एक बार स्पैन करने लग गया तो उससे बड़ा सेट हमेशा स्पैन करेगा ही, जैसे तुमने यहाँ पे देखा। तो ये स्पैन तो करेगा ही करेगा, क्योंकि ये इतना ही स्पैन कर रहा था, तो ये वाला अगर बीच में और जोड़ दिया तो स्पैन तो करेगा, स्पैनिंग में दिक्कत नहीं आएगी। और एक बार Li हो गया अगर इतना पार्ट, तो उससे छोटा इतना पार्ट Li होगा ही होगा। तो सबसेट ऑफ Li will always be Li and superset of a spanner set will always be a spanner set. But what we want the precise set, जो एक हद से ज्यादा बड़ा ना हो, एक हद से ज्यादा छोटा ना हो। तो in other words, I write in this terminology, then your basis is, so your basis is a maximal Li set, right? देखो ये बेसिस था इतना, इससे एक भी एलिमेंट इसके अंदर डाला तो now this will no longer be a basis. Why? Because this crosses the limit of maximal Li in a particular vector space. So in this vector space, the maximal Li set can have only two elements. Or we can also say that a basis is a minimal generating set or spanning set, right? So always keep in mind your basis is a maximal Li set. अगर उससे ज्यादा बढ़ाया तो वो linearly dependent ही होंगे. And minimal spanning set, क्योंकि अगर हमने उससे छोटा किया तो यहाँ पे सिर्फ x axis ही generate हो पाई. We were only able to generate the x axis because we cut down that b, right? So if we cut down that b, we'll not be able to span the whole v, right? So b is such an optimal set that it is a maximal Li set. Anything bigger than will be linearly dependent, and it is minimal generating set. Anything shorter than this will not be able to generate the whole vector space. We need to show that this will be a basis of R3. Right. So one way is true. Yani, one way is you know that how to prove that this is gonna be the Li set, that alpha 1 v1, alpha 2 v2. One way is fine, right? Another way is you can also prove the Li set by using the rank. If the rank is full, then you say that it is linearly independent. So you simply write them in a matrix form. Consider this matrix A. So operate on R2, R2 minus R1, and R3, R3 minus R1. Right? So let me put the operations over here, and you will get what? The above row will be as it is, and here you will get 1 minus 1 0, 1 minus 1 0, 0 minus 1 minus 1. So you will get 0 0 minus 1. Similarly here 0 minus 1 minus 1. So you will get 0 minus 1 minus 1. Now, simply interchange the R2 and R3. What do you get? You'll get 1, 1, 1, 0, minus 1, minus 1, 0, 0, minus 1. Is it echelon form?
Yes, sir.
All the rows are non-zero. So you simply say that your rank is full. So whenever your rank is full, so that means the matrix is non-singular and vectors 1, 1, 1, 1, 1, 0 and 1, 0, 0 are Li. So this set is Li. So next, again, you'll prove the spanning part. For spanning part, you'll do the same thing. Now you pick any vector from R3, right? So you assume that this vector can be written as alpha times 1, 1, 1, beta times 1, 1, 0, plus gamma times 1, 0, 0. So again, A, B, C. So here, so the first component will be alpha, beta, and gamma. So you add these things, alpha plus beta plus gamma. The second component will be alpha, beta, and gamma will be 0. So alpha plus beta. So the third component, that is alpha and beta and gamma, will be 0. So you have only alpha. So now you can compare. So your A is alpha plus beta plus gamma, B is alpha plus beta, and C is alpha. Now you put the value of C over here, put the value of alpha over here and you'll get the value of beta, right? So you'll get B is equal to C plus beta. So your beta is equal to B minus C. Now you have the value of alpha, you have the value of beta, you put these values alpha and beta over here, then you'll be able to get the value of gamma. So for this, A, value of alpha is C, value of beta is B minus C plus gamma. So gamma is equal to A minus B. So of course, now you got the all values. So A, B, C can be written as, in place of alpha, we'll write C, C times 1, 1, 1, 1, 1. In place of beta, we'll write B minus C, 1, 1, 0. Plus, in place of gamma, I'll write A minus B, 1, 0, 0. So that's how this set is a basis and dimension of R3 is equal to 3. Yes. Are you with me on this?
Yes, sir.
Let V be the vector space of all polynomials with real coefficients and of degree less than equal to n. Or I should write it like of degree less than equal to n and having real coefficients, right? ठीक है? हाँ भाई, समझ आ रही है? Yes.
Yes, sir.
Yes,
बताओ.
sir.
So I'll prove that B, which is a set 1x, x, 1x, x square, x cube, and so on up to xn, is the basis of V. Right? So how can I do that? I need to prove that your B is Li and B can span V. So for proving that B is Li, you consider alpha 1, alpha 2x, alpha 3x square plus alpha nxn is equal to 0. Now that 0 is nothing but 0 vector or a 0 polynomial. That means 0 plus 0x plus 0x square plus so on up to 0xn. Now, if you compare two polynomials can be equated only when your the coefficients having the same degree should be same, right? So with this definition, your alpha 1 is 0, alpha 2 is 0, and so on up to alpha n is, sorry, actually I should write it. Let me, thoda sa gadbad hua. Yes, so I should write it here, alpha naught. This is alpha 1, this is alpha 2, and this is alpha n. So your alpha naught is also 0. Yes, you're with me? Okay? Are you with me on this?
Yes, sir.
Yes, sir.
Okay. Now, second part is spanning. Spanning is quite easy. So you pick any polynomial, you need to prove that this polynomial also can be written as the linear combination of this thing. So let's say if you pick any polynomial, let's say of n degree. So let's px is a polynomial of a naught a1x plus a2x square chalte chalte anx. Now, of course, px is already written in the linear combination of x, x square, and up to xn. And here you can also write it as a naught 1 times the a naught. So it is already written in the linear combination, right? So that means it spans, right? So therefore, V spans V. So therefore, B is a basis of V. So what is the dimension of this vector space? Yes. Can anybody tell me what is the dimension of this vector space?
N.
Sir, n.
Yes. बोलो क्या होगी? क्या होगी?
N.
n plus 1. चेक करो कितने एलिमेंट हैं.
Yes, sir.
Yes, sir.
1 से लेके n तक तो यही चलेगा ना, एक 1 और है. इसीलिए that's why I have I've changed and put to alpha naught over there. Okay. So dimension of this vector space is n plus 1. So if anybody asks you what is the dimension of the vector space having the polynomial of degree less than equal to 5, then what should be the answer?
6.
6.
Yes,
6.
that's how it works. So now let's do one more example there. So let V be a vector space of all matrices 2 cross 2 size with real entries. Then you need to prove that this B, which is what? 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1 is the basis of V. Can you prove this? Is it easy? So again, first of all, what should be proved? That B is Li. And for this, let's alpha 1 1 0 0 0, alpha 2 0 1 0 0, alpha 3 0 0 1 0, alpha 0 0 1 0. In the first entry, that is alpha 1, the rest of the entries are 0, right? So your first entry in this matrix will become alpha 1. Similarly, if you take the second entry is 0 over here, only alpha 2 is there, right? So that's why this is alpha 2 over there. And similarly, alpha 3, alpha 4 should be equal to null matrix. So directly your alpha 1 is equal to 0, alpha 2 0, alpha 3 0, and alpha 4 0. So that means your B is what? Li, right? So secondly, you want to prove that B spans V. So now you pick any element of V. Now what is V? V is 2 cross 2, set of 2 cross 2 matrices. So that means any element of V will look like, so let A, B, C, D. So that's how it will look like, right? Should belong to the V. So now you want to prove that this can be written as the linear combination of, that means alpha times the 1 0 0, beta times the 0 1 0, plus gamma times the 0 0 1 0, plus delta times the 0 0 0 1. So can this be done? Yes, it is very simple to do, right? So here this sum will become alpha, beta, gamma, and delta. So of course your alpha is equal to A, your beta is equal to B, your gamma is equal to C, and is equal to D, right? So we have directly found that alpha, beta, gamma are nothing but ACD. So therefore B spans V. So therefore dimension of V is what? Dimension of vector space is what? Number of elements in the bases, and the number of elements in the bases are 4. ठीक है? अच्छा अब एक बात बताओ, if you get 6 elements over there, 3 cross 3, तो कितना हो जाती? डायमेंशन कितनी बनती? 9. Yes. और अगर m क्रॉस n मैट्रिसेस हो, m क्रॉस n वाले का लेते तो डायमेंशन कितनी बन जाती? What should be the dimension then? m times n, right? Fine, fair enough. So I'm giving you a few questions for the exercise purpose, and you may go through those just for the practice. That's it for today.